Hey everyone, welcome back to the channel. In this video, we will explore formatting verbs in Go that can be used with printf to format the output effectively. Let's dive in. Formatting verbs in Go allow to control the data displayed when using printf. There are different verbs for different data types. Let's go through them one by one. First are general formatting verb, which is %v, percent hash v, then mod t and mod or percent. Basically, what percent v does, it basically prints the value in default format. Percent hash v prints the value in Go syntax format. Percent t prints the default value of type, and percent is basically escape character which is used to print the percent sign on the module itself. So in this case, if you see, we have declared two variable I and which is float type and txt which is of string type. When we do %v for I, we get 15.15 and its Go value also looks similar. In this case, we want to print the percent sign, so we have added percent twice, and in this case, we are basically printing the type of that value. Now, when we are trying to print the string, the only difference is here, which is mod hash v, which is basically printing the string value with the double quotes, which is Go format of string. Going further, Go provides several verbs for integers also. First goes with %b, which convert the integer number or any number to base 2, then %t to which convert number to base 10, then percent plus d base 10 and always shows the sign whether it is positive or negative, and mod o small o basically to base 8 which is octal format, and mod capital O to octal format only but with leading zeros or O's. Then there is a mod X which is base 16 in lowercase, and mod capital X is base 16 in uppercase, and mod hash X is base 16 with leading O zeros basically. So these are basically hexadecimal number. Then there is %4d which pads spaces with width of 4 adjusted to right. So it is basically just adding zeros and all that stuff. Then there is mod -4d with pad with spaces. So let's see it example. So in this case, we have declared integer I as 15, and here is its binary value which is 111. Then it is basically decimal value which is 15, then with its sign, then in octal format again but with leading zeros and O's, in hexadecimal format in small letter, in hexadecimal format in capital letter, in hexadecimal format with zeros and X basically, and then there is a %4d with 4 padding to the left, and then -4d which is 4th padding to the right, and there is 04d which is basically adding 4 padding of zeros to the left. So that is the thing. Next we have string formatting verbs. Percentage basically print the values as plain string, %q print the values as double quoted string, %8s print the value as plain string, width 8 and right adjusted, and %-8 print the value as plain string, width 8, left justified. Print %x print the value as hex dump of byte values, and %x print the values as hex dump but with the spaces. Here is the example. We have hello world here, and then we have print all these values in different type. So first thing is basically plain, and then %q print it with double quotes, then %8 is add a padding of 8 spaces to the left, then -8 is similar thing but to the right, then mod x basically to hex but with no spaces, and mod with space between x, similar hex but with the spaces. Then we have boolean formatting verb which is t. Value of boolean operator is true or false, so it is simple. As you can see that we have just declared two variable with true and false, and when we are printing it, then we are getting true and false. Then we have float formatting verb, which is mod e, scientific notation with e as exponent, so it print values in format of e, exponent format. Then we have percent %f, which is decimal point, no exponent, it just prints with it with point like 2.4 and all that stuff. Mod .2f is default width with precision 2, 6.2f is width 6 with precision 2, and exponent as needed, only necessary digit for the mod g. Let's see it example. We have declared one variable with 3.141 value. When we print it in form of exponent, then we have 3.141 and e ka power 0, so it is basically telling us that 3.141 into 10 ka power 0, that sort of thing. Then we have mod f, which is basically printing it without exponent. Then mod .2f is to the precision of 2, and 6.2f, it has a length of 6 but precision of 2, and mod g is basically, I forgot, it is exponent as needed, only necessary digits. So if it is exponent needed, then it will automatically add it. Otherwise, it is basically similar to the mod f but without trailing zeros. So that's it for this video, guys. Let me know in the comment section if you have any doubts, and don't forget to like, subscribe and hit the bell icon for more Go tutorial. Happy coding. See you in the next video. Bye bye.